I've got our LED potentiometer circuit set up on the bench, and the LED's inserted. I've got the voltage source set to 3.5 volts. I've set up that little trimmer potentiometer, that's a 500 ohm trimmer potentiometer. I've set it up as a variable resistor, and you can see what I've done is there's 3 pins, the end, which we called A in our article, the center we called C in our article, and the bottom called B in our article. And I used this little staple wire to short A and C together. And so now you can see the voltage running in, and let's watch what happens when I vary the potentiometer. You should see the LED getting brighter and dimmer as I vary it. So you can see the potentiometer acting as a variable resistor. Now let's take a look at the voltage, what's happening with the voltage across the diode. So we'll go ahead and set the meter, the voltmeter, across the diode legs. And again, we'll vary the voltage, and you can see it's varying from almost 3.5. There's probably a little bit of losses in the wires, and it'll vary down as low as 2.7. A diode, an LED, isn't like a resistor device. It doesn't work fully linearly. Diodes aren't linear devices. So that's why we say they have impedance rather than resistance. And the impedance actually varies with the current that's flowing through it. And so the diode is changing its impedance. So it has some impedance. So there's always going to be some voltage drop across the diode. And usually around for this particular diode, I know that around 2.4 volts is when it'll start lighting up, 2.2, 2.3, 2.4. And then I discovered earlier exactly what point these blow out at, and it's about 4 volts is about when the diode loses its magic smoke. There isn't actually any smoke, but it just burns out and stops functioning. So that's an example of using a resistor, a potentiometer, as a variable resistor. This is the second part of the lesson. I've got the voltage divider with a potentiometer circuit set up on the bench, and you can see that I've got the 1 megohm load attached to the wiper of the potentiometer, just like in our schematic. I've got an 820 ohm resistor hooked up at the bottom of the potentiometer, what we were calling terminal B. The load resistors on what we called terminal A in our diagram. And then I did not have a 430 ohm resistor in stock. I had 470s, and we could substitute a 470, and that would work perfectly fine. It would change our parameters a little bit. But kind of to keep with the circuit that we designed, I used my trusty Heathkit resistor decade box, substitution box, dialed up 430 ohms on that, and now that's at the top of the potentiometer to limit the upper end of the voltage. So let's take a look, power up 5 volts on the circuit, and see what we get. So before I started the cameras, I actually tuned this to 3.3 volts. So I've dialed up this little 200 ohm potentiometer to get that 3.3005. It was fairly easy to do, which I'm going to demonstrate because we'll go back to it. But for now, let's take a look at the range. And so I'm going to turn this all the way one way. And you notice the range is, at the top end, is 3.497, so essentially 3.5, which was what we designed it for. And if I turn it all the way the other way, it's 2.8, which again is essentially what our design predicted. So let's go back to 3.3. We'll just take it a little bit at a time. Continue dialing it a little over, so we'll go back a little bit the other way. And if we'd have made the range a lot smaller, we'd have had much easier time adjusting it, but just kind of easing it in. This isn't the best potentiometer in the world. We would have been better off with a 10 turn, but I'm going to call that close enough. So that would be fine. Let's take our resistor substitution box and see what would happen if we had substituted in a standard 470 ohm rather than the 430 ohm resistor. So I'm going to run it through its range again. We dialed it all the way down and we're at 3.4 volts for our max and 2.74 volts for our minimum. And so again, the 470 ohm resistor would work fine and give us some range. So we'll reset it to 3.3, at least as close as we're going to be able to get, which should be fairly close. I'll call that close enough. So there you go. There's our circuit. We were able to do a voltage divider this time using a potentiometer, and it's actually a tunable voltage divider, so we can set it for whatever voltage we like between the upper and lower limits that we set.